Hi. So today we are going to solve the recent Leetcode contest problem, that is from contest 236, and the problem name is find the winner of the circular game. Now before moving to the problem solution, I would request you to please go through this problem once and then only proceed with the solution. So now let us discuss what the problem says. So in this problem, you're given with n friends and these n friends are playing a game. So these friends are actually sitting in a circular manner and they're numbered from 1 to n in a clockwise fashion. So if you are standing at the ith friend, then the next friend in the clockwise direction will bring you to I plus 1th friend. And if you are present at the nth friend, then the next friend in the clockwise direction will be your first friend. So basically what you need to do in this game is you need to start from the first friend. Now you need to count the next k friends in the clockwise direction. But keep in mind that you need to include the first friend from which you are starting. Now the last friend you counted, that is the kth friend, leaves this circle and loses the game. But you need to do this process until only one friend is there in the game. So whenever you make a friend lose, you need to move to immediately next friend in the clockwise direction. Repeat the same process again, that is count the kth friend, make that friend lose the game by removing it from the circle. And the last friend which is there in this circle wins the game. So in the given problem, you're given with the number of friends as well as the value of this k, that is the kth friend which you want to remove from the game. And you need to return the winner of the game. Let us try to understand the problem statement with the help of the example. So if there are 5 friends given to you and k is given to you as 2. So these 5 friends are sitting in a circular manner like this. Okay. Now we will start from the first friend. Now given to you k as 2. So if we start from the first friend, then you will count this as 1. Now this will be your second friend. You need to remove this friend from the circle and this friend loses the game. Now you need to move to the immediate next friend in the clockwise direction and do the count again. So you're here first. Now this will be your second friend. Again, you need to remove this from the circle. Okay, move to the immediate next friend in the clockwise direction. Now this will be your first friend and this will be your second friend this time. So remove this friend from the game. Move to immediate next. Now 2 has already been removed, so we'll move to 3 this time. So again, this will be your first friend and this will be your second friend because 4 has already removed. And you will remove this friend from the circle. Now you have only one friend left in the circle, that is 3. So this 3 will be the winner and you need to remove this. Now let us try to understand how we can approach this problem. So if we could take a queue in which we can store all the friends, let us see, can we approach this problem using that queue? So for that, let us store all the friends in the queue. So we'll push first of all the first friend, then the second friend, then the third friend, then fourth, and then fifth friend. Now let us start from the first friend. This will be a first friend. So do we need to remove this from the queue? No. So just pop this out and put it at the end because we don't want to remove this friend. But let us move to the second friend. Do we want to remove this friend from the circle? Yes, we want to remove this friend from the circle because we are given with the value of k as 2. So we will pop this element out of the queue, but we will not add this element back into the queue. Why we are pushing the element at the end? Because our friends are standing in a circular manner. So if you want to pop this element out, then you want to encounter this element at the end. So that's why we are popping this element and adding it at the end. Okay, now let's move to the next friend, which is 3. So this will be again our first friend. because we have already popped out this element and we want to move to the immediate next element, which is 3. Now, do we want to remove the first friend? No. So we'll pop this out and put it at the end again. Now the second one will be the fourth friend. So yes, we want to remove the fourth friend. So we'll just pop it out. Now let's move to the next friend. Fifth will be our next friend again, which is the first friend. So do we want to remove this? No. So we'll pop this out and put it at the end. Again, we are moving to the same procedure. Now this will be a second friend again. We need to remove this from the queue and we don't need to add it back again. But again, this will be the first friend. So we'll pop this out and put it at the end. But this will be the second friend. We need to pop this out and we don't need to put it again. So now we have only one element left in this queue. So this will be our final answer. Okay, so now I hope you have understood this approach well. Now, how to write the code for this approach? First of all, you need to push all the elements present in the circle in the queue. Then after this, we need to run a while loop until the size of the queue becomes 1. So to count every second element, we will take another integer. Let us say we'll take another integer as j. Now, if the j value is equal to 1, then at that point of time, you need to pop the element out of the queue and push it at the end of the queue. But whenever the j's value becomes equal to 2, at that point of time, you just need to pop the element out of the queue. You don't need to push it back again into the queue. And at the end, you need to return the front element of the queue. So now I hope you could code this from the queue approach. But let us discuss one more very simple approach. We have already discussed the queue approach. Another approach that we can have is using linked list. So how we could code this using linked list? Let us discuss this. Till now, we have added all the elements in the queue. What if we add all the elements in the linked list? So let us try to do so. 1, 2, 3, 4, and then 5. So these were the elements that we were having. Okay. So now again, we'll start from the first element. Okay, let us start. So this will be a first element. Now we want to reach the second element. So we'll reach the second element, that is this. And we will remove this element from the linked list. After this, we'll move to the next element. And again, we are going to remove the second element from the linked list. Okay, after this, we'll move to this element. Now, what will be the second element? The linked list ends. No, we want to reach the first element back again. So we are going to make a circular linked list. We want to reach the first element again. So from this 5, this 1 will be the second element. So we'll remove this from the linked list. Now our next element will be this 3. And from this 3, the second element is this, 5. So we'll remove this element from the linked list. Now the only element left in the linked list will be this 3. So this 3 will be our winner. Now let us code this linked list approach. Both of the approach are pretty much similar. The first approach was with the help of queue and this approach is just with the help of linked list. So let us code our problem. Okay. So first of all, the first thing that we need to do is we need to create a linked list. So let us create a linked list. We will create the linked list of integer type, right? Okay, let us name the linked list as LL only. So in the first step, we have created a linked list. Now we need to push all the elements given to you in the linked list. So for that, we are going to run a loop from a first element till our last element. Okay, so we need to add all the elements in the given linked list. Now what should be our next step? Now our next step was we want to find our kth element each time. So if you want to reach your kth element each time, you need to start from the first element, right? You need to start from the first element of the linked list. So for that, let us take another variable which will help us to traverse through a linked list. So let us name that variable as j. Now we want to traverse through the linked list. We want to keep on removing the elements through the linked list until only one element is there in the linked list. So for that, we will run a while loop. Now, how can we check that there is only one element left in the linked list? So for that, we'll get the size of our linked list. And we want to run the loop until the size of our linked list is greater than 1. Now, what we should do in the loop? We want to reach the kth element each time. So we can get a kth element by this. So is this the correct way of getting the kth element? No, this is not. Because this will give you the kth element by not counting the first element. In the question, it is given that you want to reach the kth friend by including the first friend as well. But if you are just adding k, then you are not including the first friend. So for that, what you need to do, you need to reach the k minus 1th friend. Okay, so now is this the correct answer? No, still it is not the correct answer because we want to have the linked list in a circular manner. We want to reach from the last element back to the first element. So to go through the linked list in a circular manner, whatever we have got, we will take its mode from the linked list size. So let us do the same. Let us take its mode with the size of our linked list. Why we are taking the mode again? Because from the last element, we want to get back to the first element. So I hope you have got this point till now. Now, after that, what we need to do? Sorry. Yes. Now, after this, we want to remove this element that we have reached in the linked list. We want to remove this friend from the linked list because this friend loses the game. So let us remove this element from the linked list. Okay, now you should repeat this process until there is only one element left in this linked list. Now, if there is only one element left in the linked list, then at the end, we will just return the first element present in the linked list. So this will give us the first element present in the linked list. Now, I hope you got the solution of the linked list. Let us try to submit our code. Is it working or not? Okay, let us see our. Okay, so our code got accepted. So we can say, yes, our code is working. So now I hope you could code this problem on your own. Thank you.